Hi, I'm Caesar. Welcome to this Real Python project-based video course on using pandas to create a gradebook. The Pandas module is a data analysis and manipulation tool. It's fast and it's powerful, and it's easy to use. Pandas is written on top of the NumPy module, which is widely considered as the de facto scientific computing module in Python. Let's go over what this course is about. As I said, this is a project-based course using Pandas to solve a real-world data problem. The goal of the project is to compute the final grade for each student in a large course, containing 150 students and divided into 3 sections. The data associated with each student is spread out in various CSV files. This is the type of situation that you may encounter in a real world problem where you've got different sources of data, different services providing you that data. So maybe you've got one service that's giving you, say, the name of the students and basic identifier information. And then maybe you've got another service that's keeping track of, say, homework assignments and quizzes. And then maybe another service that's keeping track of exams. And then you need to merge this data so that you can compute a final grade for each student. The grade is going to be computed using several assessments, like I just mentioned. So things like many homework assignments and quizzes and exams, and each of these different assessments will have a different weighting to compute the final grade. Although not completely necessary, you'll get the most out of this course if you know a little bit about pandas already, or maybe NumPy. If you know only NumPy, then I still think you should be able to follow along. But let me give you a few resources in case you either just need to freshen up on pandas or maybe you've never worked with pandas before. There are a few really good tutorials in realpython.com that go over some of the basics of pandas. So, working with the data structures in pandas, data frames, and series, and also just getting practice with data visualization. So, if you just need a refresher or you're very new to pandas, then check these out just to get caught up on pandas. We're also going to be using the Jupyter Notebook. And so if you don't have much experience with that, here's another really good tutorial that you may want to check out. It's Jupyter Notebook Introduction in Real Python, but it's really easy to learn. And if you're already writing code in an editor, then, this will be pretty straightforward for you to pick up. All right, let's do a quick overview of what we're going to do in this course. The first thing we're going to want to do is just explore the data. All of our sources come to us in CSV files. So we're going to be able to open these files up in an editor, just do a quick exploration of the data, what the fields are, and just to see if there's anything in particular that we may want to be careful about. Then we'll load the data and we'll be careful in case we need to do some sort of conversion of the field names in the files, just so that it makes it easy for us to, say, merge the data, which is what we'll do next. And we'll merge the data so that we get one big data frame. And then on that data frame, we'll be able to do all of our computations, which will be the fourth thing. We'll be using just basic arithmetic operations on the columns of the data frame. We'll use some of the built-in functions in NumPy, like the max function and the ceiling function. And again, just work with basic arithmetic operations to compute the final grade. So then after we've computed the final grades, we're going to subdivide all of the grades into different files, and each file is going to correspond to each of the sections. So the whole class is divided up into 3 sections, and we just want to make sure that we can subdivide the data so that we got the grades that correspond to each section, so that those CSV files can be used for other purposes like submitting final grades in some sort of online form system. And then just for fun, we'll do a little bit of plotting and some basic statistics just to give us a little bit more practice with some of these built-in features in the Pandas module. All right, so I think you'll really enjoy this course. If you like to learn via project-based learning, or if you just need a refresher with Pandas, or maybe you have NumPy experience and you want to see what Pandas is all about, then I really think you'll enjoy this course. So let's go ahead and start exploring the data. All right, let's explore the data a little bit. We'll do a lot more exploring in more detail when we actually start coding, but it's a good idea just to get a general overview of what the data is like. Here's a suggested project folder structure that you may adopt. So you can create some sort of root folder. You can give it a name, something like gradebook underscore project. And then we're going to have a main script file. Because we're going to be using Jupyter, we're going to have a .ipynb file. And if you're using just a regular Python script, you're going to have a .py file. And then when we start coding, we're going to be assuming that there's a data folder, and that folder contains all of our CSV files. There's a roster.csv file, and then a file that contains the homework and the exam grades of all the students, and then a whole bunch or 5 quiz files that contain the grades for the quizzes. And these are all structured the exact same way. So let's take a look at these individually just to get an idea of what's in them. The roster CSV file is pretty straightforward. It contains sort of the basic information about the student. So we've got the name of the student. Notice that this is last name, comma, first name. Then we've got an identifier. This is a net ID. It's all uppercase. And then we've got an email address for the students. And again, these are all uppercase. And then because this is a large university course, we've got 150 students. And what is usually done in a university course is that we subdivide the course into sections just to make them more manageable for finding rooms in the university and things like that, and also just for grading. All right, so this is the roster.csv file. Then we've got the homework and exam grades.csv file. This is by far the largest file. It contains an SID field, and the net ID and the SID refer to the same data. So here we've got a different name for a column that refers to the same data as in the roster CSV file that it was referring to the net ID. So that'll obviously be an important thing that we need to worry about when we go ahead and start merging the data. Then we've got the first name and last name for the student in 2 different fields, different than what was done in the roster.csv file where it was all contained in one field. And then we've got a sequence of grades and information about the homework assignments and the exam grades. So there are 10 homework assignments, and for each one, we've got 3 fields associated with each one. There's the actual grade for that particular homework assignment, and then the maximum number of points for that homework assignment. So for each homework assignment, this will be the exact same number. So this data here is redundant, but that's okay. That's how we get the data. And then we have some field or some column that has a timestamp of when that homework assignment was submitted. And so this pattern of 3 fields, it repeats for the other 9 homework assignments. And then we have this exact same pattern repeating for the exams. So we'll have an exam 1 field with the grade for that exam, and then the exam 1 max points field for the maximum points for exam number 1, and then a timestamp as well. And then we'll have this for exam number 2 and exam number 3. Then we've got the quiz grades CSV files, and these are all structured in the exact same way. So we'll have a last name field, the first name field, and then email address, and then the actual grade that the students received in that particular quiz. The maximum number of points for each particular quiz is not included in the file. And so what we'll do is when we're actually coding, we'll just simply either define a list or a dictionary that contains this information that we can use when we compute the average of the quizzes. And then there are 4 other quiz files. There's 5 in total, and they all have the exact same structure. Now, notice one thing that here in the email address field, all of the emails, they are in lowercase, whereas in the roster file, all the email addresses were in uppercase. So these are just some things that we have to keep in mind when we load the data and we merge the data so that we're, in essence, normalizing the data in some way so that it all looks the same and we don't have any risk of either missing any data or duplicating any data. And so we'll deal with this when we actually load and merge the data. All right, so let's see what we saw with the data. Well, each table has a different representation of the students' names. So for example, in the roster CSV file, the last name and first name were all in one field, and it was just simply a string separated by a comma. Whereas in the homework exam grade CSV file, we had 2 separate fields, one for the last name and one for the first name. And then the students' email addresses, they don't have the same elements. Now, there is a standard pattern, which is the first name and then the last name. But if this is not a unique string, then the university system would go ahead and add maybe an extra digit somewhere to modify an email address if it's not unique. We also saw that some of the columns, in particular the net ID and the SID in the two different files, they refer to the same data, but the names are different. The field names are different. And so, again, this isn't a key thing that we'll have to make sure that we're aware of this when we're merging in the data. And then each of the table, they sort the data differently. Pretty much of it is randomly sorted. And so, again, we can't rely on this when we're merging or loading in the data to have some sort of predefined sorted structure. And then lastly, some of the tables, they have missing values. So again, we'll have to make sure that we do something when we load and work with the data to deal with these missing values when we're doing the numerical computations of the final grades. So that's a quick overview of what the data looks like. Why don't we go ahead and jump in and start loading the data and then start computing? Before we get going, I want to make sure you've got your environment all set up for this course. So there's a couple of ways that you can go about this if you've never used Jupyter before. So from the terminal, what you could do is first create a virtual environment that will contain all of the modules that you need for the specific project. This is in general a good way to do things so that you're not creating any conflicts with modules that maybe you need for one project and the modules that you need for this project. So you would use the virtual environment module in Python and create a folder inside your project folder, which you can call VNV or whichever name you want to give it. So this folder will contain a Python installation, and any of the modules that we install for this course will be saved in this folder. So once you've created the virtual environment, you'll go ahead and activate it with the second line and then use pip to install all of the modules that we need, which can be listed in a requirements.txt file. And then once that completes, all you do is from the terminal type Jupyter space notebook, and that will fire up a Jupyter server and a instance of Jupyter in your browser. Now, in the requirements.txt file, in each line, you simply type in what are the modules that you need. And for this particular course, we're going to need NumPy, SciPy, Matplotlib, Pandas, and of course, Jupyter. So just create a simple text file. In each line, write down these module names, and that's the file that needs to be also contained in the project folder. So that's one way to get going with all of the modules that you need for the course. Another way is to use the Anaconda distribution. The Anaconda distribution is a Python distribution that comes pre-bundled with a whole bunch of tools and modules for data science. There's an open source version that can be used for individuals, so you can head on over to anaconda.com and check out the individual version. So the individual edition comes pre-bundled with all of the modules that you would need for data science like NumPy, Pandas, SciPy, and Matplotlib. And it also comes with Jupyter Notebook, Jupyter Lab, and a nice IDE called Spider that I highly recommend. So let me quickly go over this for you so that you just have everything to go. I'll start off first with the terminal version of getting everything installed, and then I'll go over Anaconda. I'm on a Mac machine, and so if you're using Windows, the instructions that I'm going to give here are going to look a little bit different. So check out the video description on how to go about this if you're on the Windows platform. I'm at the terminal prompt, and I'm located in my home directory in the gradebook project. And inside this folder, all I've got is the data files, which contain all of the CSV files, the quiz files, the homework exam grades, and the roster CSV file. And I'm going to create a Python virtual environment so that I can install all of the modules that I need. And so I went ahead, I created this requirements.txt file, and it contains all of the modules that I'll need. And I also threw in IPython, which is a interactive REPL for Python. So we're going to need NumPy, SciPy, Matplotlib, Jupyter, and Pandas. So, what we need to do first is create a virtual environment. And so I'll do that with the virtual environment module. And I'm going to create a folder, which I'll call VNV in the gradebook project folder. And this will contain my Python installation, which I will later activate so that we can have a self-contained Python installation for this project. So go ahead and run that. It'll take just a few seconds. Now let's activate this virtual environment. So we need to navigate to the bin directory, which contains the activate script. And so now any module that I install will be contained in this virtual environment folder that we created, which is contained now in the grade project folder. So now let's use pip to install all of the modules that we listed in the requirements file. And this will take probably just 5-10 seconds, depending on your connection and CPU. Go ahead and run that. And so we'll start downloading all of the modules and installing them in this virtual environment folder. All right, so that completed. Let's clear that up. And now we have Jupyter installed. So let's run that. And with Jupyter Notebook. So now we have a Jupyter server running. And so let's go ahead and create a new notebook using Python 3. And let's go ahead and save this as the gradebook notebook. And then we're all set to go. If you're not interested in setting everything up via the terminal, or if you prefer to have a complete data science Python installation, then I highly recommend the Anaconda distribution. So if you head on over to the Anaconda website, click on the individual edition, and if you scroll all the way down or click on the download button, you're taken to the different installers, and depending on whether you're on a Windows, Mac, or Linux machine, download the graphical installer, probably the easiest way to go, and then install Anaconda that way. And once the installer completes, you'll open up what's called the Anaconda Navigator, which looks like this. And it comes, as I said, with a whole bunch of different packages and modules and tools, like, for example, Jupyter Lab, which is sort of the new version of the Jupyter Notebook. And we've got, of course, Jupyter Notebook and Spider. And so if you launch Jupyter Notebook that way, you'll get, again, a server running, and the Jupyter Notebook will open up in your browser. So if you're new to data science and Python in general, and maybe you have experience with other packages and other programs, then I recommend Anaconda, and you'll find that you've got most of the modules that you need to get going with Python and data science in general. But once you launch the Jupyter Notebook, you'll be all set to go, just like we had it set up with the terminal version. All right, so let's get going and start coding. All right, we're all set to load the data. So we're going to be using the path class from the pathlib module. And this is just going to make it easy for us to create paths to the different files that we need to load up. So if you're not familiar with the path class, maybe this will be a good introduction to its use. And you'll see that it's pretty easy just to use it to load files by creating path objects to them. So we've got the path class that we're going to be using. And then, of course, we're going to be using Pandas. So let's load that in. And we're also going to be using the NumPy module. We're not going to be using NumPy right away, but we might as well load it now. All right, so we've got those few things loaded. So from the path class, we can get a path object. So this will be creating a path object to the current working directory. Remember that you should have the structure to your project so that you've got a data folder containing all of the CSV files. And so my current working directory, where I have my Jupyter Notebook, is contained in the project directory. So I'm going to create this variable, say current directory, that contains this path object to my working project directory, and then the data directory, which contains all of our CSV files, that's simply the data folder. All right, so these are two path objects that you can sort of almost treat like strings and we've got these operators, like for instance, this slash operator that will create a path. And we'll see how we use that later. All right, so we've got these path objects. We're all ready to load the data. I'm going to create just a little bit of markdown here to tell me that this is going to be the spot where I'm loading in the roster. Now, to change a cell from a code cell to a markdown cell, you just press escape and then hit the M button and then type in your markdown and then just run it like a regular cell. You can hit shift enter and then you'll get a new cell that creates a new code cell. So let's go ahead and run that. Now, we know that the Pandas module contains a read CSV file. So let's go ahead and read the roster file. So we've got the data directory path object, and we just simply need to add in the roster.csv to the path so we can point to the file that we want to read in. So if I run this, we get our roster data frame. So this creates a data frame. And what we're going to do is we're going to start normalizing some of the data. So if you recall, the net ID and the SID point to the same data. And here it's all uppercase for the net ID, whereas the SID was all lowercase. And then also the email address, in this case, they're all uppercase. And so we'll also want to sort of normalize it to say lowercase. And this ID field is some sort of internal ID that we're not really going to use. It might be a database ID or just some other ID that really won't necessarily be useful for us to identify a student. So we won't have to worry about that ID field. And then we saw that we've got the different values of the section for the students. So why don't we go ahead and do some conversion for some of the fields that are coming in so we can pass to the converters keyword argument in the read CSV file a dictionary that contains the keys are going to be the column names that we want to affect or that we want to change as we read in. And what we want to do is just call the lower method from the string class to convert all of the net IDs to lowercase letters. And then we want to do the exact same thing for the email address field. So let's go ahead and do that. And this will be all lowercase. And then another thing that we want to do is we don't care much about that ID column. So let's be explicit here about what columns to use when we read in the CSV file. We certainly want the section and the email address and the net ID. And for the moment, we're not going to worry about the name. We'll get the name later on when we read in the different quizzes or the different homework files. And then lastly, we want to define the index of this data frame. We want it to be the net ID. And so the final data frame that we construct is going to have as the row index the net ID. This is going to be the unique identifier that we're going to be using to uniquely determine each student. All right, so that's going to be the roster data frame. All right, let's run that. And let's just take a look at the first, say, 10 student names. All right, so that looks pretty good. Let's now load the homework assignments. So I'm going to go ahead and put a little bit of markdown there. We're going to go ahead and load the homework and the exam grades file. Now, this is going to be similar to the roster file. So we're going to read in using the data directory object, and we're going to go ahead and read in the homework exam grades CSV file. Now, if you remember, the only thing that we were concerned here was that the SID was in lowercase. And although we know that all of those SIDs were in lowercase, it's good practice just to make sure that you are guaranteed that everything is going to be converted to lowercase, because that's what we're doing with the net ID. So we're going to go ahead and do that. Unless we go ahead and view each row by row visually and manually, we're not guaranteed that these all come in lowercase. So there's no harm in go ahead and making that conversion now. Now, if you remember the homework exam grades file, it contained the timestamps of when either the homework or the exams were submitted. And this isn't really important to us. And so, what we can do with the use columns or the use cols key argument is that we can pass in a callable, and it's going to keep any of the field names or any of the columns where the callable returns true. And the columns that we want to omit are the columns that contain the submission timestamp. And so what I'm going to do is use a lambda function that will only return true if in the field title, the word submission is not in the title. Okay, so just to make it clear, what this is doing is we've got title, right? The field title. And as long as that field title does not contain the word submission, those are the field or the columns that we want to keep. Again, the timestamp when these homework assignments or exams were submitted is really not all that important. And so, as before, what we want is the index to be the SID, which was the same data as the net ID. All right, so go ahead and run that. Let's call this the homework exam grades. And let's take a look at the first few or so just to make sure. All right, so this is again the largest data frame that we're going to be constructed from the files. We're going to have a much larger data frame, but this is the largest file. And so again, we've got all these 10 different homework assignments. Then we've got the exams, and they have, again, max points and so on. And same thing for exam number 2. And we got rid of all of these submission columns because we're not concerned about when those different assessments were submitted. Okay, so we've got the grades for the homework. And then the very last one that we want to load in are the quizzes. All right, so now we're ready to load up all of the quiz files. So let's go ahead and put a little bit of markup here, and we'll just say load quiz grades. And if you remember, these files were called quiz, and then the number of the file, and then grades, or the number of the quiz. And then we've got CSV file, and there were 5 of these quizzes, so 5 of these files. Okay, so we're going to load those up. Now, the way we're going to do that is we're going to create one data frame to contain all of the grades, all of the quiz grades. And so what we'll do is we'll need to loop over each of the quiz files, load them up as data frames, and then simply concatenate them to a running data frame that we're going to create as the final one that contains all the grades. So let's create an empty data frame, and we'll call it quiz grades. Now, the data directory, this is a path object, and it's a directory. And so it contains this, we can use the glob method that will match a pattern and that will return a generator. All right. And each of the elements that the generator returns is a path to the file matching the pattern. So in this case, the pattern is quiz, right, underscore. So that wildcard character is what's changing in the different file names. And they're all named underscore grades CSV. So this will return a generator, and we want to loop over the generator, and it's going to be returning a file path that matches the pattern. And what do we want to do with this file? Well, we're going to want to read it in, obviously, get the CSV file. And what we want to do is the data frame that we're building here, it's going to contain 5 columns for each of the different quiz grade files. And what we want to do is we want to call each of those field names just either quiz 1, quiz 2, quiz 3, depending on what file we're reading in. And then the index or the indices of the quiz grades data frame, we're going to be using the email address. If you remember these quiz files, they all contain the email address for the student. So here's what we'll do. Let's load up individually each of the quiz files. So this is similar to what we did before. We're going to read in the CSV file, and This is going to be, of course, the file path, right? That is as we're looping over the objects returned to us by the glob generator. These are just simply file path objects. And so that's the file path. And then we want to do the conversion again that converts the email field, all of the elements in the email field, into lowercase letters. And we're going to use the index to be the email address. If you remember, in all these quiz files, we had just the first name and the last name of the student, email address, and then just simply the grade. We're going to use the email as the index of this data frame. And then the only columns that we care about are going to be the email address and the grade of the quiz. Then we are going to take each individual quiz and we're just simply going to concatenate it to this running quiz grades data frame. So we'll concatenate the running quiz grades data frame with the current quiz data frame. And we want to do this along the second axis. So we don't want to stack these data frames. We want to concatenate them along columns. So in other words, we're adding a new series or a new column containing the current quiz grade to this quiz grades data frame. So let's go ahead and run that, see what we get, see if this makes sense. And let's take a look at the first 5. Okay, so this looks good. The only thing is that, of course, because all of the fields or all of the columns in the individual quiz files were all grade, then that's what they come in as, right? When we concatenate them into the quiz grades data frame, they're all the same name. Now, of course, we know that if these were put in where this one was the first quiz, the second quiz, the third quiz, and the fourth and the fifth, assuming, of course, that the glob object generated them in that order, and there's no guarantee that that's going to happen. So what we want to do is, before we concatenate the current quiz, let's rename the column grades. So we need to pass in a dictionary, and the column or the field that we want to rename is the grade one. And what we want here is basically we need to pull out this information from the file path object, right? Because that's going to contain the quiz and then the number. And so here what we'll do is before we pass that into the rename of the columns, let's create a, say, quiz name variable. And so we're going to take this file path, right? It's like a string, but it's basically a path object. And this path object contains a stem variable. And so this is a string that will contain only the portion of the path object that's at the very end without the suffix CSV. All right. So essentially, we're going to be getting quiz, the number, and then grades, and that's what's in the stem. And then we're going to take that string and we're just going to capitalize the first letter of the string, which is quiz. And then we just simply want to split by underscore. And we want this number, but we might as well just keep the quiz as well. So this will create a list. And so right now, this will be a list containing the elements quiz, number, grades. And we only want the first 2 elements. So we're going to go from the first to the second. So we go all the way up to 2. So that'll be a list. And then all we need to do is join using a blank space so that we then get just the word quiz capitalized and then with a space and then the number, right? So this is essentially going to give us quiz 1, quiz 2, quiz 3, and so on. And so that is what we want to rename the grade field when we create this data frame. And so here we'll pass in quiz name. All right, so let's run this again. Oh, we got an error. All right, so it looks like I just forgot to write down that I want to join that list of elements, only the first 2, just with a blank space. All right, so let's run that again. Okay, that looks good. And then if I run this again, there we go. We've got the field names where the column names are just whatever quiz we loaded at that time. So notice that the glob method doesn't guarantee that there's any type of sorting being done. It's just sort of whatever the generator returns to us is the order in which we're going to be creating these fields or these columns, and that's fine. All right, so that loads up all of the quizzes. We've got them all in the quiz grades data frame, and we've got all of the homework and exam grades in this data frame called homework exam grades. And then lastly, of course, we've got the roster. The roster contains just the net IDs, the email address, and then the section number of the student. And so now we want to take all this data and merge it and create one data frame that contains all the data. And so we'll do that next.